Hi everyone. In this video, I'm going to demonstrate several Venn diagram examples to help you do your homework. If you watch all of these 5 examples in this video, you should be able to do all of the Venn diagram application homework problems. So let's get started. Let's look at the first one. In all of these Venn diagram problems, the key is first, you need to be able to identify, you need to use a Venn diagram, right? How do you identify this is a Venn diagram application problem, right? First, whenever you have something that splits the whole thing into different groups, that's where you need to consider Venn diagram. And let's take this first one as an example. There were 40 people on the bus. 20 of them were hat, and 29 of those were glove. If 8 of them were neither hat nor glove, how many people were both hat and glove on the bus? So basically, they split this 40 people into different groups. Some of them were hat, some of them glove, some of them both, some of them neither, right? What split this 40 people into different groups? Because that thing that separates all of the people into different groups are hat and glove. Whenever you have something that splits the whole thing into different groups, that's very likely a Venn diagram application problem. Here we have two different things. One is hat, one is glove. That is corresponding to two circles or two sets in your Venn diagram. So let's do that. So we draw a rectangle to represent the universal set. And we have 40 people. So this universal set, and U equals 40. And since we have two sets, we're going to need two circles. We always draw these two circles this way so that they partially overlap. They are partially overlapped. So one circle represents hat, one circle represents glove. Apparently, this overlap region represents people who wore both hat and gloves, right? Okay. Now, after that, we need to fill in different regions with data. Let's call this region number 1, this overlap region number 2, this number 3, and this number 4. Now, let's read the information. We always fill out this overlap region first whenever you create a Venn diagram. So this represents people who were both, right? How many? Now this actually is our question. We don't have that number, so we use X to represent that. We use X to represent unknown, right? Now after this, after we fill in the overlap region, the rest actually is easier to do. This is X. Second step, let's fill in the first region. All of the rest of regions, like region 1, region 3, and region 4, you can do either of this, any one of this first as the next step. Doesn't matter. They have no priority one over another, but you do need to fill in this overlapped region first. Apparently, this is region 1, which represents this portion of the head set, and we use set head subtract the region 2, subtract X. How many people were head? Excuse me. 20 of them, right? 20 subtract region 2, which is X, equals region 1. So 20 minus X, that represents how many people were only head. Now, third step, region 3. It's like in region 1, we use a glove set or glove circle, subtract X. So how many people wore glove? 29. So this equals 29 minus x. Now we are given that 8 of them were neither glove nor hat. So that's region 4, because region 4 is outside both hat and glove circle. So region 4 will be 8 people. So put it in here. Now I'm going to put all of these numbers in different regions. The first one is 20 minus x. This one is 29 minus x. Now, in order to answer question, which is our x, we need to set up equation to solve unknown, just like in algebra, right? What is our equation then? This Venn diagram always have the same equation. Since these two sides split the whole universal set into 4 different regions, when you add them up, all of these 4 different regions, it will be equal to the universal set. So let's just do that. This is the first number, this is the second one, this is the third one, this is the fourth one. So 20 minus x plus 29 minus x plus 8. This should be equal to 40. Now we just need to solve this equation, right? Now plus x minus x cancel out. We can add all the 3 numbers together because they're all on the same side. They're all positive numbers. So let's do that. 20 plus 8 plus 8 plus 29 equals, we got 57. So 57 minus x equals 40. Now let's minus 40 on both sides to solve this equation. We get let's actually, it should subtract 57. We want this x to be on one side by itself. So minus 57 minus 57. Negative x equals negative 17. So x equals 17. If you multiply negative 1 on both sides, or divide by negative 1 on both sides, either way is okay. So we solve it. X represent people who were both, right? So this is a question. So this answer is 17. Now the most important part through this example is that you need to be able to go through this process, set up a correct Venn diagram with data in different regions, and then you use the equation to solve unknown if there's any unknown in it. Okay, so basically this is the example that we solve for the overlapped region. Now let's look at our next example. 178 people were awarded on the show. 200 people were awarded for dancing, and 146 people were awarded for singing. How many people were awarded for both dancing and singing on the show? First of all, this 278 people represent those that were awarded. So first, identify what splits all of these people into different groups. Apparently, it's 2 different categories. One group of people were awarded for dancing, the other one for singing, right? So we still have 2 circles because we have 2 different things that separate the whole group into subgroups. So the basic structure is the same. This time, one is the dancing, one is the singing. And our universal set is 278 because it is this 278 people were separated into 2 different groups. That means all of the 3 regions add together in the end will be 278 because these 278 are all we have. They all awarded, but they get awarded for different things. One is dancing, one is singing, right? So as usual, we identify the regions, number 1, number 2, number 3, number 4. Now we always fill out these regions starting from overlapped one. So it's first step, overlap region, this represents people who awarded for both dancing and singing, just like this one, just like the previous one. So this one is unknown. We don't know that number. Then region 1 equals dancing circle subtract region 2, which is X. So how many people were awarded for dancing? That's 200. This is X, by the way. 200 minus X. So this is 200 minus X for region 1. This is the region 1. In a very similar manner, region 3 equals people who were awarded for singing. That number is 146. So 146 minus X. 146 minus X, that represents this region 3, which equals the whole circle for singing, which is 146 subtract X. Now we don't have any people in the region 4 because the 278 people represent those who were awarded. So all of the 278 people are distributed in these 3 different regions. So now we need to solve unknown by adding the 3 numbers together equal to that. Actually, this is 0. And 200 minus X plus 146 minus X equals 278. And this 2 cancelled. We add these 2 together. This is easy. We don't need a calculator, right? So 346 minus X equals 278. Now we minus 346 on both sides. Negative X equals, so I'm going to use 278 minus 346, negative 68, and X equals 68. So the answer is 68 people were awarded for both dancing and singing. So we answer this one also. I hope through these 2 examples, you can see some similarities between the 2, right? There's no really fundamental difference. You just set up this basic structure and fill in the data, set up equation, and solve the equation. Now move on to our next one. Of the children in Rick's class, 13 of them like gym and 10 like science. So we have 2 different areas, subjects, gym and science. 7 children like both gym and science. How many children like gym or science or both? First, don't worry about the answer. We need to set up this basic Venn diagram structure. It's key to have Venn diagram first. Don't try to look at the numbers, try to guess the answer. We have 2 different things that separate all of children in Rick's class into different groups, and those things are gym and science. So we have these 2 groups or 2 sides or 2 circles. So this is gym and this is science. Apparently this is both, right? Now this time, different from the previous 2 examples, we are given this number, 7 children like both. So here is our region number 2, by the way. Number 1, number 3. All these labelings, you can label different ways, you just identify which region. So we have 7 children here. So region number 2 equals 7. Now look at region number 1. Because the gym circle subtract 7. How many people like gym? 13. So this is 13 minus 7, which is 6. Region 1 has 6 children in there. And region number 3, how many people like science? For the whole science circle, we have 10. So 10 minus 7 equals 3. So 3 is in region 3, which represent people, children actually, who only like science. Now, do we have anything else? Say, of the children in Rick's class, 13 like James, 10 like science, 7 like both. How many children like gym or science or both? So basically, this from the information we assume the children in Rick's class, any one of them, given any one of them, they at least that person like one of these two. That means there's no people in here which represent those children who didn't like any of these two. Okay. Now here, the key to get the answer is understanding this question. And if you attend my class face-to-face or watch my lecture video, you understand this or really means really equivalent to the union. Gym or science or both. That means they represent all of these three. We need to include all of these three, no matter that children likes a gym, likes a science, or like both, right? Apparently, we need to add the three together. So the answer is 6 plus 7 plus 3, and that is 16. So 16 children like at least one of these two areas, science and gym. Maybe they like both. How many children in his class? We don't touch that question because that question is irrelevant. We only look at children who like at least one of these two areas. Okay, let's move on to the next one. Number 4, all students in 3rd grade ordered storybooks or math books. That means, so the universal set represents all of those students who ordered either book, because all of students ordered at least one book. Now, 95 students ordered storybooks and 116 students ordered math books. If 55 students ordered both, how many students were there in 3rd grade? That means we are looking for the universal set, because how universal set, total number of students were separated into different groups because of this two different kind of books. So we still have two sets represent two different books, which separate the whole universal set into different groups. So storybook, math book, right? And as usual, this is region 1, region 2, region 3, and region 4. Let's fill in data. Region 2, that represents those who order both, right? That's 55. I'll put 55 here. And region 1 represent people who only ordered the storybook, which equals the whole story circle subtract 55. How many people ordered storybooks? 95. So 95 minus 55. Is that right? Yeah. That is 40. So that means 40 people only ordered storybooks. Now, region 3, region 1, I mean. This is region 1. Sorry about that. This is first step. I already know that the region 2 is 55. This is region 1. That's 40. Now, region 3. We use a math circle, subtract 55. How many people order math books? 116. So 116 subtract 55. I'll use a calculator to make sure I don't make silly calculation mistake. Minus 55. 61 equals 61. So that means 61 students ordered only math book. Now, how many students were there in 3rd grade? This is region 4. Region 4 equals 0 because among all the students in the 3rd grade, they ordered either storybook or math book. That means there's no people who didn't order any books. So that's 0. So we are asked how many students in the 3rd grade. That means we need to add all this together, all of these three. Because all of these 3 areas are distinct areas, there's no overlap. When you add them together, it's exactly total number of students. So answer is 40 plus 55 plus 61. 40 plus 55 plus 61, 156. So totally 156 students. How do you know this is correct? If this number is correct, it has to fit into all of these descriptions. First, how many people ordered storybook? If you add these two numbers together, that's 95. How many people ordered a math book? Which is 116. Add these two together because these two numbers belong to math circle. It's 116. How many people order both? 55 order both. That's why we know the answer is correct. Okay, the last one. On the test of two problems, 17 students solved the first problem correctly. 13 solved the second problem correctly. 9 solved both correctly, and 2 solved neither correctly. How many students are there? So we're still finding the universal set. Now, first of all, how do we know how many circles involved? Even though in this QR course, you are only required to be able to create a two-side Venn diagram. But outside this class, outside this course, if you have a similar problem, nobody can guarantee you only need two sides Venn diagram. That's why we need to identify how many sets or how many circles you need in Venn diagram. So what split this total number of students into different groups is those two problems. So we have two problems. That's why we have two circles. This is represent those who the first circle represent who solve the first problem, this number one problem correctly, okay? This second circle represent, let me get a new pencil. Those who solve number two problem correctly. Apparently, this overlap region then represents those who solve both problems correctly. Make sense? So number one, number two, number three, number four. Now let's fill in these different regions. First step, overlap region. Do we have this number who solve both correctly? 9. 9 people solve both correctly. Now, region number one, which represent who only solve the first problem correctly. This number one region equals whole circle, subtract 9. Whole circle means those who solve the first problem correctly, right? 17 students solved the first correctly. So this whole thing is 17. Subtract 9, I get this region. So 17 minus 9, that's 8. So 8 is here. Now look at region number 3, apparently which equals the second problem circle, subtract 9. How many people solved the second problem correctly? 13, right? So 13 subtract 9, that is 4. 4 in here. And number 4 represents this number 4 region is outside both circle, and this circle represent those who solve at least one problem correctly, right? So region 4 really means those people who didn't solve either of this correctly. Okay. So do we have that number? Yeah, we are given that number. That's 2. So region 4 equals 2. Now the question is, how many students are there? So all of the students, this whole universal set, U, is split into 4 different regions, and we have numbers for each of these regions. So we simply add them up. It will be equal to the whole thing. That is the universal set. So this is 10, this is the 13, this is 9 plus 4, 13, so totally 23. So that's our final answer. Among 23 people, 17 of them solved the first problem correctly, and 13 people solve the second problem correctly, and 9 of those solve both correctly, and 2 of those didn't solve any problem. Okay, that's the end for this video. Probably I'll see you in the next video if I feel there's a need to do another video.